Okay, so once again, you are most welcome. My name is Mtanda Samir. Please, as you are nearing to your name, of course, we have just a few days to our final exams, that is O level senior 4. Please, we are also pushing harder as far as the revision items are enough, of course, are concerned. Sorry. So realize that here we are in for item 19 or 019, which means that in our playlist, if you can check, we have right there from item 1 or item 001 up to item 19. Of course, I know by watching each and every video up to where we are right now, we'll at least get you somewhere as far as physics revision is concerned. Of course, we know as we teachers, we tend to teach the notes, but the time may not necessarily allow us to go deep into the scenarios and also how to revise them. Okay, now also unlike other videos I've been making, this is a special one, by the way. And of course, in item 18 or item 018, for those who watch it, please, we happen to show, in fact, somewhere I put an image trying to show that the image must be upright. But of course, we need to make some corrections here. I think we are going to make some bit of corrections here. And please, we call you to subscribe to the channel. Okay, of course, that's the only kind of appreciation you can give back to us. However, I appreciate for whoever reaches out to me and is there a list to give a way how we can get this improved. Okay, and in one way we are getting this item 018 corrected a little bit. Of course, I put and I thought maybe someone can easily understand it, but I know to students they may not necessarily pick it. So item 18, this is the simple correction I meant to have right here. Okay, now please, so you realize that in the item 18, okay, let me just give some clarification here. For those who have not yet watched item 18, can correct it. For me, I put the image right here for the sake of just for you to know that it is meant to be upright, and that's how it appears if you look into the video. Though, however, the characteristics of plane mirrors, the images are formed behind the mirror, if you can really see that. So the image of this, now for you as a student, you are meant to just draw it just like the way I'm going to leave it for you here, just like that. Don't bother to show where the image is, or in simple terms, the real science would be that anyway. Okay, I don't want to go into that, but that's how you are meant to draw. Here we have the observer's eye. Okay, the correction is that we are not meant to put the image right here, just because we know that the plane mirrors don't necessarily form real images, but they form virtual images, and in physics, virtual images we use dotted lines. Okay, but if you don't know how to clarify that, you can just leave it as this. This will make some sense a little bit, yeah, like that. And of course, that has been just as a by the way. Let's now proceed to the real work. And now watch this video to the end. Each video has got a learning point. What if it is the video which you may at least have something or give a reflection in the forthcoming exams? Of course, no one knows, but we're just saying what if it is the video and you just watch it halfway. Don't wait for regrets, watch the video to the end. All right, we go there. Alright, so again we remind you to subscribe to the channel. Please, I even told you that soon or later we shall be restricting our channel to strictly our subscribers. So don't be caught offside. Make sure you subscribe such that we are on the same page. Then also I'd want to send out my regards and appreciations to whoever stood with our video editor, okay, and the one in charge of uploading the channels, the videos on the channel. Please, thank you very much for whoever turned up. Anyway, I will not mention the amount collected, but just know it was some good amount and we indeed appreciate. Okay, item 18 had the details concerning the way forward on how to condole with our technocrat as far as our YouTube channel is concerned, and is really happy. Okay, he's a man who does not disclose his face right here, so he chose not to bring it here, but just know he's very thankful, and he has indeed seen that maybe anyway you guys love him so much, and of course he loves you too. All right, without wasting time, let's get to the channel, or rather the video. Okay, all right, good. So here we are. Okay, so we have our scenario just right there. Now I think without wasting time, let's proceed and we look at this channel, rather this video anyway. I don't know why I'm just keeping on mentioning the one channel. Sorry for that. So we start off. So, but before we start, please, I kindly appreciate for whoever is able to condole with our technocrat. We are really thankful. We don't know how we can Okay, thank you, but we can just say thank you anyway to thank you. Okay, so we start the saying. The physics department has been experiencing minor thefts of equipment such as spring balances, lenses, mirrors, and many others. Oh, that's really bad. The laboratory has one entrance and a storage shelves. Storage shelves located at the corner, which is at one side of the lab. Oh, they're located at the corner anyway, which is at one side of the lab. The laboratory attendant sits at the point near the doorway. At the point near the doorway. Okay. The school has no money to install expensive CCTV cameras, and yet this vice should be stopped. Anyway, don't you think advising the students would work here? Can that work anyway? Advising them and telling them not to again steal. Anyway, we have to answer this in a physics way. Okay. During the study visit to one of the banks of River Nile, okay, they noted that one boat transports people as they cross the Nile. But when the boat is on one side, when the boat I think it's meant to be when the boat is on one side and people want it this side, a whistle is used to call, and the student noted that it takes 0.5 seconds for the sound to be received again. Not that word again, I've highlighted it in green. Okay. The students were inquisitive. Alright, so let's proceed. 0.5 seconds for sound to be received again. The students were acquisitive to know. Now, acquisitive means interested in. They were interested. So the students were acquisitive. Or you can just say the students were interested to. Okay, I think. But just not means inquisitive. So the students were acquisitive, sorry, not inquisitive, to know the width of the river at that point. But the locals had no idea. Of course, they are locals after all. We move to the next part. All right, so there we are. Now let's get the hint here. Right here, we still continue with this. So now the hint, they're telling us that the speed of sound is 340 meters per second. Of course, this is speed of sound in air, or just speed of sound. Okay, now we are saying part A, use an illustration to explain the type of mirror to be used, giving reasons why it should be the type to stop theft. Okay, part B, explain any other application of the mirror used in A above. Okay, shall be there. Help the people at the bank to understand the width of River Nile at that point. Okay, now with this, let's first of all get back here. Remember, in here, we are analyzing part A so we can get it answered. Okay, use the illustration to explain the type of mirror to be used. Okay, then you must give reasons why we are picking that mirror. Anyway, let's go there. So only to go back here, let's go back here. You look at this. So look, we have now, we are going to get a picture of this. So the physics department has been experiencing minor thefts of equipment such as, anyway, why were they calling it minor? Okay, such as spring balance, it's a bit expensive, lenses, mirrors, and many others. Now, so when you look at this here, they're saying the laboratory has one entrance. Maybe this is our lab. If you can really see, getting a picture of this. This is our lab, like that. Okay, and this is our entrance, maybe right there. So the laboratory attendant sits at a point near the doorway. I think the lab attendant sits right here on the desk. Okay, and I think he's watching stuff which are right there. Okay, the school has no money to install expensive CCTV cameras, and yet this device should be stopped. Okay, now it means that, all right, now what if these equipments are in this corner here, right here, the equipments are right here, there, so it is very hard for this lab attendant to view all these things here. I hope you can really. And now if we have the, okay, there is some statement I saw here when they were talking about the shelves. Okay, shelves, to explain what a shelf is, a shelf in the library, an organized book library, you realize that there is that, sometimes they're made of wood, but having, okay, a shelf may be like this, having sections where they place books. That's how a shelf looks like. The order is wooden, and some libraries, they can put a shelf there in a way that if the lab attendant is here, cannot easily see what is this side. It will be very, very impossible. Now you're asking, which type of mirror can work for him? Now, if you talk about mirrors, think about these three guys. When you talk about mirrors, think about these three guys. Okay, not forgetting what you know of a plane mirror. Think about what we call a concave mirror. All right, next, think about what we call a convex mirror. Now, can you really, which of these can you use? Which of these can you use? Remember this one here, a plane mirror cannot necessarily work, but the plane mirror cannot work here. Now let's look at a concave mirror. A concave mirror with it is converging. It is a converging mirror. In a way that if you have a mirror like this, light rays come from very far, if you can really see that, light rays come from very far, and like that, they converge at a certain point. So this can't really work out for us, meaning that it will give us a very small field of view. What about a convex mirror? A convex mirror with it, it is in this format with the coating inside. It bulges outside in simple terms. So if rays, mean that if rays come and they are incident on this mirror, they are diverged away. So for example, if this ray comes like this, okay, maybe if that ray comes in that format, this ray will be diverged in that order and it appear to be coming from a certain point right there. So the rays are diverged in that order. Now, this diversion from here up to here is what we call a field of view, meaning that once this ray, where the rays are, the distance between each ray there is the area which will be captured, and is the area which the lab attendant will be able to see, if you can really look into that. So now we need, which type of mirror we're going to use here. With that explanation, I think you can at least think about something. Anyway, let's go and get this part A answered. Which one is the best mirror we can use out of the three? Plane mirror, concave mirror, convex mirror. But we have called off the plane mirror because it cannot work for us here. As far as field of view is concerned, it cannot really work for us here. Okay, let's now go and look into this. Let's begin with this guy. Now, to look into the science of the mirrors, look at this. Now I have these two guys here. One answer, part of the answers of what we need in this question is right here. Now, I'll also ask you a little bit. Try to think, which mirror will work out for us here? Look, this one here is a concave mirror. This one here is a concave mirror right there. And this one here is a convex mirror right there. I hope you can really see. Now you can see that the reflecting surface is inside. What I'm meaning is that when light rays come on this mirror like this, when light rays come from this mirror like this, they will converge at a certain point like this. And that's the kind of image you shall have. You have to look into that. Now, the rays which have been converged away, these rays, the distance between these two rays gives us a field of view, and you see we're just forming something small right there. Now, look into this. What if when the rays come, the rays come from far away and they are incident on this mirror? What happens here is that when the ray is coming like that, this ray will be diverged away in that direction, and it appears to be coming from a certain point there like that. Then also, if another ray parallel and close to the principal axis is incident on there, it will be reflected away like that. Now, the distance between this ray and this one which are reflected, of course, I think you can see these arrows here, will tell us that the bigger, so that there is a larger area here, and for whoever will be seeing with the eyes, right? So you realize that there we have what we call a wide field of view. Here we have a wide field of view where the rays are. We can easily view stuffs which are all there. Okay, now what does it mean? In simple terms, it means that these rays, in order for them to work better, say for example, I'll give an example here. Like if you have our house, maybe this is our house, like this is our house, and this is our door in there. Now this mirror can be placed just right here like this, whereby this mirror, now look, if the rays come from this area, and the incident on it, you look at it, at that, okay, and rays come maybe from this area and the incident on it, like that. Now we find that here these rays will appear to be diverged maybe away in that order, or also here are diverged away in that order, but they appear to be coming from a certain point I, meaning the image will be formed here, meaning that this whole area from here up to here can easily be captured in this mirror just right here. So now, of course, still again, which mirror is going to work for us here? Okay, is it this one? I'll call this one mirror A or mirror B, or you can use the naming that concave mirror or convex mirror. Think about that before you go into this. Okay, anyway, you're right about that. I think you're also thinking about this. The mirror which we specifically use here, I'm going to put a tick for you. The mirror we specifically use here is simply this. Okay, and I hope you really got it there. And I know if you picked this, here is the emoji for you. If you picked this, then that is your emoji for today. Accept that. And if your mindset or if your reasoning was giving you this, then of course, here we are. Okay, a smile for you. Anyway, let's proceed. Now with that, let's go and look into this. So we have agreed that here we're going to use a convex mirror. Now, to help you know what to call a field of view, are you seeing, when you look at this mirror here now, these are the bookshelves. This is more like our lab, you see? These are books. And even far the other side. And even far the other side, we are able to see. Far the other side, far the other side. I mean that if our lab attendant is right here, can easily see what is happening in. Are you seeing that we have a white? Now this is our mirror. Our convex mirror right here. Now, you see that the mirror can see the book which is near here, and also the books which are far away the other side. Also, the books which are far away the other side. I hope you can see that. That's what we mean by wide field of view. Or that aside, what if when in your schools or home setting, you see, we have the mirror up in the corner. Now, if you look at this mirror, it shows that it's up in the corner and can easily view the other side. Now, here also in the room, you see that it is just right here, but it can view even something at the other side, the other corner. Oh, is this a TV screen? I can't tell. Now, okay, a TV screen right this side. So we can easily see. Now, what you're seeing there is what we call a wide field of view, which can, of course, be got by other mirrors. And with that, let's get this rating. Why do we choose convex mirror? Which mirror? Convex. And why do we choose it? Let's get there. So this we shall say. Let's get this here, right there. Please, a simple reminder, at the beginning of the video, we have made correction in item 18. So make sure you go and look into the changes made straight away. And of course, still, we want to tell you that maybe you also go and watch item 18 as well. Why do you even make the corrections? First, go and watch it such that you can really know what we are about here. So now here, let's make the analysis. They're saying the lab technician should install a convex mirror, which has a wide field of view. I've explained that, and can be used to monitor a wide area. You can really see here. In addition, it forms upright virtual images which can be clearly identified. The upright, of course. Now, just imagine if you're using a type of a mirror and okay, upright means that these girls, you can really see them that they're upright. Now, upside down is when maybe their heads, it appears like that. Heads down and legs up. That can really work. So, it is a good one indeed. Now, with that, let's go and look at part B. Let's go and look at part B. They're saying here. Part B, they're saying, explain any other application of the mirror used in A above. Don't you think we have other applications just from, apart from using it in the lab, apart from using it in the supermarkets, apart from using it other stuff you can be knowing? Don't you think we have others? Now this one is again very, very interesting. We go pictorial a little bit. So here we have this. We are going to go pictorial here also, and we look into this. All right, good. So now we are again reminding you that these mirrors can be used for security. These mirrors can be used for security. Why? To check underneath cars. And of course, I guess you have ever watched this in movies, if I'm not mistaken. Anyway, you ever watched this in movies? Anyway, how to say in real life, but it's in rare occasions that they use this in Uganda. Okay, so the mirror is moved below the car, and since it has a wide field of view, all parts below the car can be seen. Now what you're meaning is this. I see this mirror, this road here, and I have a continuation of our mirror. So they do, this is our car. They will enter that mirror in there, holding the road aside, and then they'll be able to view the spike parts under the car. Maybe they have planted there a bomb. You ever watch that in movies? Now, what comes with these mirrors, they're a bit special, is that they may have a sensor. They may have a sensor for any they may have a sensor, maybe which can, of course, bombs are made of nuclear energy, so they can have a sensor which can detect a bomb or just anything. You never know. So that's about that. One use of the convex mirrors is that they can be used by security to check underneath cars, and we have got that picture one there. The next we are saying the mirror can be used in reflecting telescopes. Now here, back in the days, you realize that there was a Frenchman called Cassegrain. Cassegrain made what we call a reflecting telescope, or sometimes they call it a Newtonian telescope. So this Cassegrain telescope here is a reflecting telescope. Why did they make it? Now what you must know is that most of the telescopes are made of lenses, and lenses tend to undergo what you call, okay, a chromatic aberration and spherical aberration. Okay, a chromatic aberration is when, say for example, an image is formed, but it is not all that clear. It's, I don't know how you read this. Is it blur like that? Or an image is formed and it has other colors versus on it. Okay, just when the image is not clear. So once a telescope is made of only lenses, it has got some what you call defects. So as a way to call off those defects there, a French scientist called Cassegrain had to go in to make what you call a reflecting telescope, or a reflecting telescope, and part of the telescope is a convex mirror. You can really see here this convex mirror, just part, not, of course when people look at this they think that maybe they're using necessarily all, the whole telescope is made of that. Not really. Now you realize that this mirror here is a concave mirror, but we appreciate we have a convex mirror right in there. Why that convex, why do they use mirrors in there? Is to call off all lens defects, and that means that instead of forming an image which is blur, then the image you formed will be very clear. Hope that really makes some bit of sense, right? So with that, I think let's again proceed. Now they're saying the mirror can be used as a driving mirror. Yeah, we have it right in picture 3. Okay, maybe someone's just seeing picture 1, picture 2, and picture 3. So in picture 3, I think someone is seated inside here, but can easily see a car coming right behind him or her. So that's what we call it can be used as a driving mirror. This one is also a convex mirror right there. Okay, part B has been successfully answered. Let's, I think, go to part C, the last one, and we call it a day. Okay, right here. So we have part C the saying. Part C the saying, all right, help the people at the bank to understand. Now at the bank to understand the width of the river Nile at that point. Now what I want you to see here is that, remember, as these people are standing right, alright, so I think with this, let's proceed. Let's first of all resolve this. Okay, pick some pen here. Okay, good. Now you look at this. They're saying during the study visit to one of the banks of the river Nile, they noted that one boat transports people as they cross the Nile, but when the boat is on one side and the people want it this side, a whistle is used to call, and the students noted that it takes 0.5 seconds. Now time here, not here, we have time is 0.5 seconds for them to receive the sound, for sound to be received again, not that word again. Okay, the students were acquisitive to know the width of the river at that point. Now let's go and see. Now we have the time is 0.5. Then also remember that we have in the hint here, we have that the speed of sound in air is 340, but we want the distance. Let's go there. Now that's the picture of what you're going to use as our study guide. Now realize that if what you call a bank is this area here, towards the forest, we call it a bank. Even this side towards the forest, we call it a bank. Now this one is our river. Now what you should know is that maybe I'll resolve this. Maybe the students are just right here, waiting. The students are just right there, waiting. Just know there are very many. Okay, waiting. Now one of them maybe makes a whistle. As a whistle goes this side, then they hear it again. Are you seeing that? So there is that distance of a river, said D, and another distance also D, a distance 2 and a distance 4. So we add the total distance moved by the sound will be to what? To D. And with that, let's get this in summary. So we have, so now for echoes, velocity is got from 2D over T. Now hearing the sound again means that the sound first went and came back, and that simply tells us that we are dealing with an echo in simple terms. So it means that we have D2, D4. That is two distances covered. So we have velocity is equal to, velocity is same like speed, please. The word velocity is the same as speed. Okay, in layman's language, not really, but just to a simple understanding, velocity means speed. Okay, now with that, let's get this answered. So we had T, velocity as 340 meters per second, and time was 0.5 seconds. So we're going to substitute. We put this right here, and we put the T right here, then we get the D. So let's go there. Okay, so we have that substituted. We have that, this 0.5 is right here. So we substitute, or we simplify. So multiplying both sides by 0.5 here, cross multiplying, this is over 1, shall have that. So 340 times 0.5 will get 170, but you want this way, divide both sides by 2, this will cancel out to give us a D equals to, when you divide this by, okay, by 70, you get 85, like that. So let's get that right there. Okay, so the distance is 85 meters right there. So now what does it mean? It means that we need to conclude that's the, now here the distance, or the distance of the river from the point where the students were. Maybe the students were here and the boat was right here. So the distance D is now 85. Okay, we simplify, or we conclude and say the width of the river Nile at that point, at that part, is 85 meters. As simple as that. Okay, so we are ending there for now. Thank you.